Welcome back. In this video, we're going to go through a few examples of calculating z-scores with this z-score formula, and we'll also go through some points that I want you to know and understand about z-scores. So this is the formula that we'll be using to calculate z-scores in this video. To turn a data value into a z-score, you subtract the data value by the mean and you divide by the standard deviation. And this is the formula in symbols. It's data value x minus the mean divided by the standard deviation. Um, I'll also be posting a separate video explaining all of the symbols we'll be using in this class. Make sure to look over that video sometime soon because you'll need to be familiar with those symbols going forward. So here's our first example of calculating a z-score. So we're imagining that a population has a mean age of 35 and a standard deviation of 7.2. And what we want to know is, in this population, what is the z-score of a person who's 40 years old? In this question, we're going to be turning this age of 40 into a z-score to get this person's z-score. So what we do is we take 40, the age that we're interested in, we subtract it by the mean of 35, and divide by the standard deviation of 7.2. Notice how all three numbers are provided. We have the age that we're turning into a z-score, the mean, and the standard deviation. So we subtract 40 by 35, and we get positive 5. We divide by 7.2, and we get positive 0.7. And that is our z-score for this person. Here's one more example. So here, a population has a mean age of 35 and a standard deviation of 7.2. We want to know in this population, what's the z-score of a person who's 32 years old? So it's going to just be the same formula, 32 minus the mean of 35, which is here, divided by the standard deviation of 7.2, which is here, and we get negative 3 divided by 7.2, which is negative 0.4, and that's the z-score. Notice how this z-score came out to a negative number. If it comes out to a negative number, it just means that the person is below the mean. The person is below average. You might remember from a couple of videos ago that I told you that a negative z-score is below the mean, a positive z-score is above the mean, and a z-score of 0 is right at the mean. So here's the third example. So a population has a mean age of 35 and a standard deviation of 7.2. And in this population, what's a z-score of a person who's 35 years old? Well, you might already know that it's going to come out to 0 because the person is right at the mean. But let's see it happen right here. So the age of 35 minus the mean of 35 divided by 7.2 standard deviation. So 35 minus 35 is 0, and 0 divided by 7.2 has to be 0. So that's the person's z-score. Now I want us to go over a few bullet points of the things that I want you to know and understand about z-scores. So first of all, this is just a recap of what we've already covered. So a data value equal to the mean has a z-score of 0, but data value below the mean has a negative z-score, and a data value above the mean has a positive z-score. Also, a data value further from the mean has a larger z-score. So a z-score that's far below the mean will have a big negative number. A z-score far above the mean will have a big positive number. So all I'm really saying here is that a z-score tells you two things. It tells you if the data value is below or above the mean, and it also tells you how far from the mean the data value is. Point number 5, if two data values are the same distance from the mean, but they're on opposite sides of the mean, those two data values will have opposite z-scores. The z-scores will be the same number except having different signs. So in a certain population, if one person is 10 below the mean and another person is 10 above the mean, those two people will have the same z-score, the same absolute value, but the signs will be different. One will be a negative, one will be a positive. Also, two data values with the same z-score are equally extreme, even if the two people are from different populations. So a z-score allows you to compare two people from different populations and decide which person is more extreme. And I'll actually cover this point number 6 in the next part of the video.